Let's proceed to the next presenter. Our next presenter is Dr. Ryan P. Vicerra. He's also the Vice Chair of the Manufacturing Engineering Department of the De La Salle University and a full professor of the Department of Manufacturing Engineering also, De La Salle University. He was the 2019 last outstanding scientist, and in 2017 he was awarded also as the IEEE Asia and Pacific Outstanding Volunteer. He's a professional electronics engineer, and he's very known on research. He published more than 85 Scopus Index papers. His expertise includes artificial intelligence, robotics, swarm intelligence, biomedical devices, control systems, electronic circuit design, and many. Ladies and gentlemen, I'm proud to present to you Dr. Ryan Rhay Vicerra. Rhay?
Good morning, everyone. Thank you, Doc Elmer, for that very kind introduction. So, I'm very happy to be here this morning, and I'll be presenting to you or giving you a report about our ongoing project, the BRAVE project. BRAVE stands for Bomb Removal Automated Vehicle. So also within this project, we have a simple research that we were able to share during the AUN conference in Vietnam last year, and it talks about the design of a 3D printed three-finger robotic gripper and defector. So I'll be giving you a slight presentation about the gripper and more on the bomb removal automated vehicle, or the BRAVE. So in behalf of our team, so I'm Doc Ryan, and I would like to present to you our core team, of course, our project leader, our host for this session, Professor Elmer Dajos, and we have some personnel. Of course, we have Dr. Kalilong, we have Engineer Jason, Engineer Dino, Ms. Rania, and the faculty members of the Intelligent System Laboratory of De La Salle University, and Police Colonel Gabayan and Police Colonel Jonathan Oreta. And in this project, many PhD and MS candidates are also involved. So let me mention some of them. So for the PhD candidates, we have Engineer Arvin Fernando, Engineer Regan Galvez, Engineer Ren Vedrus, Jason Rogelio, Tony Ilahi, and Jason Maningo. And we have many MS candidates. Actually, some of them are not illustrated here in the slide. Okay, so the rationale of the project is to help the PNP EOD K9 group. EOD stands for Explosive Ordnance Devices group of the PNP. This is to give them more equipment and training to enhance the capability and performance towards success in mitigating the threats of bomb in our country. So the solution is to create a Filipino-made bomb disposal robot that will help them perform bomb disposal tasks. So as you can see in the photograph here in the slide, these are some excerpts from the internet showing the most tragic bomb cases in our country. So the specific objectives of this project, the first one is to strengthen the PNP EOD K9 group. And then next is to apply the engineering design principles in developing the bomb disposal robot. Okay, and then lastly is to ensure proper utilization of the bomb disposal robot in bomb disposal practices of the PNP K9 group. So before I go with the development and show you some pictures, let me discuss to you how this robot is being used in their operation. So the bomb disposal process actually starts this way. You know? So here's a picture of a typical scenario wherein the Brave or the bomb disposal robot um, will approach a suspected EOD or an explosive ordnance device. So of course, we still don't know what's inside. So it is still a suspected EOD. And in the presence of a suspected EOD, a human agent may be at risk if he or she will approach it. So the Brave will be the one who's going to approach and perform the EOD process as follows. The first one is to inspect using a mobile X-ray unit. And then second is to identify if the explosive qualifies for water bomb disruption. Okay, because there are some types of bomb that is not qualified for disruption, no? So another method must be performed. So if it qualifies, and then it will carefully place the water disruptor near the box or the suspected EOD. Then Brave will detonate the water bomb disruptor, making the suspected explosive device soaking wet and will not detonate anymore. If a water disruptor is not enough, a high pressure water cannon may be used. So to illustrate this process, so let me show you again a very simple illustration. So the X-ray system is composed of the X-ray emitter and the X-ray film. So this will be positioned by the Brave robot. And then after that, if it qualifies for bomb disruption, a bomb disruption module will be placed near the suspected explosive, and then remotely, there's a tether connecting the robot and the disruptor. Remotely, it will disrupt the suspected EOD. So this way, all the electronics and everything inside will be dismantled, and the bomb will no longer be operational. No? Okay, in the event that disruption is not possible, one way also is to use a high pressure water cannon. And that water cannon can be placed in the arm, one of the arms of the Brave robot. So as you can see in this illustration, the Brave robot is a mobile robot with two robotic arms. The two arms, we call them as the claw arm. Okay, obviously because it has a gripper at the as an end effector, and then the weapon arm is an arm where we can connect the high-powered water cannon. Okay, so this is the Brave block diagram. No, so the Brave robot will have 6 cameras. And of course, it will pass through the video acquisition system, and then it will go through the wireless communication module. And then for the electronic control system, it has 6 actuators to control the 2 arms and the wheels of the robot. Of course, it will pass through the actuator drive system, and it will be controlled by the control system. In this case, we use a Jetson board, and then the communication module also communicate with the control system and also with the remote control module. And then, of course, there's the power management module connecting the battery source to the whole control system. And here's an illustration or a conceptual illustration of our Brave robot. So as you can see, it has wheels and the mobile base, and it has the 2 arms. So the weapon arm As you can see in this illustration, the water cannon is not yet inserted because that is another product that is sold separately. So we will put it here or install it here, and then this is the claw arm. And for this design, what's illustrated here is a 3-claw gripper, the one that we presented in AUN, the one I mentioned a while ago. And I'll also be discussing a bit about that. Okay, so here's another rendered view of the Brave robot. And here's another version of it. So here are the specifications of the mechanical components of the mobile base. Okay, so again, so I'll be just showing you some of the pictures of our Brave robot design. Okay, and this is still one overview of the project. And here are the wheels. Okay. As for the motor, we use a brushless DC motor, similar to the one that we use in electronic bikes. Okay, and for the claw arm, we have the wrist assembly that will be connecting the claw arm to the whole assembly of the arm. And this is for the weapon arm. And this is the gripper that we developed that I shared to you a while ago. This was actually in cooperation with some of our students or graduate students, namely Mr. Dino Ligutan, Mr. Jason Espanola, Richard Tanay, Dr. Argel Bandala, myself, and of course Elmer Dajos. So the concept of this paper is to design a 3D-printed three-finger robotic gripper and defector. So this is the an illustration of it showing its dimensions, and these are the parts, no, that we 3D printed, and we use Autodesk Fusion 360 for the CAD drawings and for the designing of the 3-gripper robot arm. So this 3-finger configuration is expected to improve the gripping reliability and stability if we compare it to a 2-finger design. So the design is actuated by a linear actuator, and the dimension is should have at least an opening of 30 centimeters. So the assembly is divided into modular components, which allow us for reuse of the 2-finger or multi-finger configuration. And also we applied modularization. This will help us the reusability and ease of process when we are already machining the final version of this design. Okay, so here are just some of the illustration that we got during our presentation, and we shared this during that conference. And at this point, I would like to share to you the progress of our metalwork fabrication. And at the end of this series of pictures, you will see that the Brave project has already been took its mechanical form or mechanical frame. So this is the mobile aluminum frame. Okay, so, and these are the gripper finger plates, the arm mechanism support plates, and the gripper bar links. And we have these bushings, linear actuator caps, so extended tube blocks, mobile base wheel mount, and then we have this joint for the linear actuator attachment to the aluminum profile base. And then we have this, the linear actuator mount for the arm mechanism and also arm mechanism support plates. And this is the wrist assembly. Okay, so these are still some of the mechanical parts. So this is one of the final version of the one of the finger of the 3-finger gripper. So this is all what this slide discusses the electronic system block diagram of the Brave robot, and this was already discussed a while ago. And this is the electronic system block diagram of the system. And this is the wheels that we will use. This is an aftermarket system, typically used in electronic bikes. And of course, some of the electronic components that we will be using, and some components available in the market that we'll be using in the electronic system. Okay, this is an illustration during our testing in the laboratory. And this is the 3D printed prototype of the whole weapon arm. As you can see, there is also the 3D printed version of the 3-finger gripper, and this is the wrist box, and these are the linear actuators. Okay, and this is the arm control architecture. Okay, again, some illustrations showing our simulations and setup in the laboratory. And this is an illustration of the mobile controller. So our team has just started doing this. So I cannot show you some actual photograph of this. So this is just a rendered photo of the command control unit. And this is the state machine diagram for the controls. Okay, so in some photos of our simulation. Okay, so this is the just recent photograph of our Brave project from our fabricator. So as you can see, it's already taken its final form. So you can see the 2 arms, the weapon arm and the claw arm, and of course the module for the arm and the attachments are not yet installed in this photo. And this is some pictures of our team conducting some collaboration with the PNP EOD group. And they are actually inspecting the market available bomb disposal robot available abroad. No? The PNP EOD group received a donation of this ICOR robot. And this is actually the benchmark for our Brave robot. And this is a photo of our team. In this event, we were actually able to see the process, how to dispose or how to disrupt bomb. And this is a photo of our team. This is just recent, so obviously you can see that all of them are wearing masks. So with that, I would like to end this presentation, and thank you very much for the opportunity.
All right, thank you very much, Dr. Ryan. Okay.